In this video we're going to look at how you solve absolute value equations, and we'll just do that by jumping right in and taking a look at some. Here's an absolute value equation we can recognize from the absolute value signs that you see right here and right here. So once you know it's that type of equation, you can always follow these techniques to be able to solve it. First thing we're going to do is we're going to isolate the absolute value part. That's this part right here. Anything else we need to get to the other side of the equal sign. So we're going to do that right out here. We're going to move the plus 5 over to the other side of the equal and subtract it from 11. So it will be 11 minus 5 on the other side of the equal, so it'll be equal to 6. And so the problem we're actually going to solve is this one, absolute value of x minus 6 equals 6. Now we do that by dividing it into two cases or two equations. We're going to rewrite the absolute value equation exactly as it appears for one of the cases, only we're going to leave off the absolute value sign. I'm going to leave the bars off. And then for our second case, we're going to rewrite the absolute value part without the absolute value sign, but we're going to change the sign on everything on the other side. In this case it's only 6, so we're going to make it negative 6. So we're always going to rewrite into two cases, one that looks just like the original once we've isolated the absolute value, only it doesn't have the absolute value sign, and the other will be like the original, but the side opposite the absolute value, we're going to change all of the signs from, in this case, positive to negative. So now I'm going to solve each of these little equations. First one here, I'm going to move the 6 over and add it to 6. So that means x is 12. And on the other side, I'm going to move the 6 over and it will become plus 6. Negative 6 plus 6 is now 0. And these are my two potential answers. Now with an absolute value equation, you always want to check the answers you get, because many times you will generate extraneous solutions, which are solutions that don't really work in the problem. So I'm going to go right back here and I'm going to plug each of these numbers I got into the original equation. So 12 minus 6, putting 12 in for x in the original equation. And I'm going to ask the question, is it equal to 11? And so now 12 minus 6 is 6. The absolute value of 6 is still 6. Absolute value of any positive number just remains positive. And so this is a true statement. 11 is equal to 11. Therefore this one checks. And I'm going to go ahead and just circle this one to indicate that's a valid answer. I need to do the same thing for the one on the right. I'm going to substitute 0 back into the original like this. I'm going to ask the question, is it equal to 11? And negative 6, the absolute value of negative 6 is positive 6, which means it changes to plus. Absolute value of any negative is always positive. And again I see that 11 is equal to 11. This one also checks, so that is a valid solution. So in this case, both solutions I got were valid, and I have my two answers for this equation. Let's take a look at another one here. So this time, it's already isolated. This is by itself. So now I'm going to solve this problem by making two cases. X plus 10 equals 4x minus 5, just rewriting the original problem without the absolute value sign. And then x plus 10 equals, now I'm going to change every sign, minus 4x plus 5, like that. And again, I'm going to solve the equation. So this time I'm going to group my x's on the left, bring that 4x over, it becomes minus 4x plus 1x is negative 3x. I'm going to take the 10 over, make it negative. Negative 10 and negative 5 is negative 15. And then finish solving the problem by dividing by negative 3. So this x is 5, And on the other side, again, I'm going to bring the negative 4x over, and it becomes positive 4x plus 1x is 5x. Going to take the positive 10 to the right side of the equation, making it negative 10 plus 5 is negative 5, and I'm going to divide by 5, whatever's in front of x, to finish the equation. So my other potential answer is x equals negative 1. So since it's absolute value, I'm going to check my results by plugging in for the original x, both numbers, in this case 5 first, and I'm going to ask, is this equal to, notice I'm also going to plug 5 in for this part of the equation, anywhere x appears, and I'm going to find the answers on both sides. 5 plus 10 is 15. The absolute value of 15 remains 15. 4 times 5 is 20. 20 minus 5 is 15. These check, therefore this is a valid answer. And do the same thing over here with negative 1. Going back to the original equation, negative 1 plus 10. I want to know if that is equal to 4 times negative 1 minus 5. Whoops, kind of messed that up. And again, I'm going to work out the problem. 10 minus 1 is 9. The absolute value of 9 is still 9. And on the other side, 4 times negative 1 is negative 4 minus 5 is negative 9. I have a problem. 9 is not equal to negative 9. Therefore, negative 1 is an extraneous solution that I can mark out. I'm not going to use that as a valid answer. In this case, my only valid answer is x equals 5. We'll do one more here. Need to first isolate, since there's a plus 5 on the side with the absolute value. So I have 2x minus 1. I'm going to move the 5 over, and it will become negative 5 plus 1, which is negative 4. And now I'm ready to make my two cases. 2x minus 1 equals negative 4, rewriting the first time exactly as it appears without the absolute value sign. And then 2x minus 1 equals the opposite sign, positive 4 this time. And I'll solve each equation. Move the negative 1 over, it becomes positive 1. So negative 4 plus 1 is negative 3. And over here, I guess I should finish this one. Divide by 2. And x equals negative 3 halves. And then over on the right side, again I'm going to move 1 over, add it to 4 this time, and divide by 2. And x is equal to 5 halves. Just leave these improper. Those are my potential answers. Now I'm going to plug them into the original equation here. So negative 3 halves times 2 minus 1, I'll put that out of order, is that equal to 1? Let's see, the 2's will cancel, that's nice. Negative 3 and negative 1 is negative 4, but the absolute value of negative 4 is positive 4. 4 plus 5 then, is that equal to 1? Well, no, that's 9 equals 1, and that's not true. So this one is an extraneous solution. Let's see if the other one works. Put them in order this time. 2 times 5 halves minus 1 plus 5, and we want to know if that's equal to 1. We'll cancel. 5 minus 1 is 4. So 5 minus 1 is 4, and absolute value of 4 is also positive 4, plus 5 again. And that means we get 9 here, and again 9 is not equal to 1. This is also an extraneous solution. So in this case there is no solution. I'll just put my empty set sign to indicate that there is no solution that will get us a valid x where that x will solve this absolute value equation. And that will happen sometimes. Hopefully that will help you with your absolute value equations. If you want to see other topics or work some problems of different kinds, I invite you to go to my website where the videos are a little bit more organized by topic. You'll find that at www.mymatheducation.com, and we have a lot of different videos on a lot of different subjects there. Thank you for watching this video. Hope you'll come back and see some more of my videos to help you out on your different algebra topics. Thanks again.